Hey YouTube, CyberCDH here, hope you're doing really good. Today's video is all about Remcos. We're going to take a super quick look at a Remcos infection chain. It's pretty convoluted, but pretty straightforward to analyze. But really what I want to do is show you a cool trick that you can use to super quickly extract the key indicator of compromise from Remcos, which is the network indicator of the bad guy who's going to receive all of your stolen data. We've got lots to get through, so let's dive right into this one. Okay, so we start live in the VBA window here, and so we'll just fly through the macro code and all of the infection chain, because really what I want to concentrate on in this video is how to extract the config of Remcos itself and get you the C2 of the bad guy that's going to be receiving all of the stolen and harvested data from the endpoint. But just to give you a kind of flavor for the infection chain, we'll just quickly go through what kind of attack scenario that you will see. So here's the VBA window here, all of the macros. What I tend to do is strip them out and just tidy it up a little bit in Sublime Text. I find it a little bit easier to read. And so we've got workbook activate, and that's obviously going to execute when the macros are activated. And so we can see that the output of textbox1.text is going to be stored in this variable, which gets fed into a routine here, this rgirl routine. There's a couple of things that go on here. Firstly, there's a call to get object, and the get object, the input to that is the output from this shd function defined down here. And we can see that that takes a big long string and reverses it using this function, this private function here, this hpjcimvnc function. That all of this code looks pretty meaty, but actually it's just a string reverser. So if we take this string, put it into CyberChef, we can simply reverse it, and we get this string here at the bottom. And if we do a quick Google, we can see that this equates to a COM object. So you can see this class ID here for the COM object for WSH, which is the Windows script host. And so that enables the .run instruction as part of the Windows script host, and it will run the PowerShell that we'll just see in a minute. So go back here, we can see we want to find out what it's going to run on the host, which is going to be sheets1, and it's going to execute the contents of textbox1.text. A couple of ways here. You can see I've disarmed the malware by commenting out this code. Set the value of textbox1.text to visible because it's hidden on the actual worksheet, and also we can debug.print that as well. This is what it looks like in the debug.print window. We can see it's reversed. We can see the actual text box that's hidden with all of this weird and wonderful encoded data that looks like binary. So let's strip it out. We're going to use CyberChef for that. We'll just use the string reverse routine in CyberChef, so we get all of the decoded content. We want to just strip out the binary stuff of interest. We'll just take it from binary, comma delimiter, and we just tidy it up a little bit, and we can see we get a nice bit of PowerShell, and we get ourselves a nice little C2 indicator as well, which is just going to download content from this remote location, invoke it from the app data folder as notepads.js. So we can see here is we hit that C2, here is the data, and it's all more encoded binary stuff, but a little bit of tidying up to do. Copy all of that stuff out into Sublime Text as well. Again, there's the weird encoded binary stuff that we just need to tidy up, and then it just gives a little bit of persistence and a few other little bits and bobs that go on in the actual code. Nothing too interesting about this though. But what we want to do is strip out all of that binary stuff. Very simple like we did before, but we just want to replace the caret symbol with a 1-1, which is what the code tells us to do. That gives us the binary. We can then just take it from binary, do the tidying up, and again, it gives us a little bit more code to read. In this case, it's PowerShell again, and it just does a ping to Google, and then it tries to bypass AMSI logging, so PowerShell logging, and then pulls content from a remote location. Again, in this particular case, it's attack.jpg, and then it splits it on the % symbol, and then it's going to execute that. It's going to invoke expression IEX at the end. So here is the content of that remote location. We need to split this on the % symbol. We can do that again in CyberChef, so just feed it split on %, and we take it from its hexadecimal character code, and we can see we get yet more PowerShell. Put this into Sublime Text again to make it a bit more readable. You can see at the top here we get a variable as SD4 SD000 is set to these character codes, and what you'll find, something worth remembering, 73, 69, 88, that equates to the string IEX, which is invoke expression for PowerShell. And we can see here there's a set alias for IEX, and so anytime you see Y0DF5 called, that's actually going to be an alias for IEX. And we can see that down here we get something that's piped to IEX using that particular alias. So a few things that stick out at me. We got some weird variables which look like we have some string replacement going on, so super easy to decode all that kind of stuff. But the ones I'm really interested in is this weird string here and also this weird string here. So this WXB string and this MVLA string. And so the WXB one starts with 45A, so we can see that this is probably some kind of executable content. And then the MVLA string, well, we've got a little bit of work to do to find out what this is all about, but this will actually turn out to be the Remcos binary that we're interested in. We can see something that we're interested in at the bottom as well. We can see a call to waves. We don't know what waves is just yet, but we can see there's a call to a particular method here. This Y78HJ routine takes two parameters, notepad.exe and MVLA2. MVLA2 is the output of MVLA, which is our weird string. We don't know what it is just yet, which goes through this routine, which basically converts it all from hexadecimal once it's been tidied up of these string replacements. So flown through that obviously, but it is super simple to go through and work your way through. When you do that, I'm going to strip out the first one first. So this is the 45A particular string. Stick this into CyberChef, do the simple find and replace on the Chevron app, replace that with 00. We get ourselves a nice executable content. We can pump that into Windows. We can see the first thing here, it's written in C# in .NET, so we can use something like dnspy to reverse engineer this. It's a DLL, and also we get the compiler timestamps as well, which is super nice. So secondly, what we want to do is just double check here, right? So we've got this waves routine. It's going to get past MVLA2, and it's going to pass it notepad as well to this particular location. Well, what is that all about? We really want to focus on this MVLA parameter, and what is this big long crazy string? Well, we can see if we go into the DLL, so the one that we've just written, this 45A, if we go into the DLL and we can find the routine of interest here, this Y78, it takes a string RT, it takes the byte buffer FFDF, whatever, but it decompresses it. So we know that that big long weird and wonderful string that gets passed to it is decompressed with gzip, and so that's what we need to replicate ourselves. We can do that using CyberChef, just pump it into CyberChef, do the simple find and replace there, take it from hex and then unzip it, and we get again the executable content, which is Remcos. Stick this into PE Studio. You can see it's Visual C++, so we can't use dnspy. We can see this is pretty recently compiled, and if you run strings on this particular binary, there we go, we can see that it is in fact Remcos. It gives it away, it doesn't really hide itself, and it's super easy to analyze this in a debugger as well. But what we're interested in now is dumping the config from Remcos, because Remcos is a remote access tool. It can keystroke, it can compromise data on the underlying system, but it's going to pipe that back to the bad guys over the internet. And really what we want to do is find out if we can quickly and easily grab what that C2 location would be, so we know who the bad guy is without actually running the code. And there's a trick that you can use to actually dump this config out super easily, which is what I'm going to show you next. Okay, so now we've got the Remcos binary itself. We can stick this in a debugger, we can poke around it till our heart's content, no problem. It is pretty straightforward to analyze, but what we really want to do is extract the key indicator of compromise, which is the network indicator, the C2 of the bad guy that's going to receive all of our stolen data. Well, you'll notice that in PE Studio, I really like the fact that it draws your attention using colors here. We can see that in the resources, we've got something that is unknown. We have a resource with the name of settings, and it's fairly substantial in size. And so what we want to do is actually dump this out and poke around it. This is the encrypted config of Remcos itself. So what we can do is just dump raw. We can save this, and we'll just save it as res.bin in our downloads folder here. I'm going to open this up in a text editor, and we can see what is going on. Well, what is going on is just a bunch of encrypted content, load of gobbledygook, doesn't make any sense to us. This is RC4 encoded. If you looked in the binary itself, you'd be able to see that there is an RC4 decoding routine that this goes through. It's fairly straightforward to pick up and analyze, but one thing to notice about RC4, firstly, is the code needs to know what the key is in order to decrypt it. The actual key itself is not hard-coded in the binary, it's hard-coded in this data, and that's the little trick that we need to know. But we need to know how long the key is. So it could be a few bytes, it could be many bytes. And in this particular case, the code needs to know the same thing as well. And the way that it does that, it looks at the first byte for the key length. So the first byte in this config is the actual length of the key. So this is C1 bytes long, which is obviously hexadecimal for 193. So it's 193 bytes long in this particular key. And so what we need to do is take C1, so we got C1 as the length. So the next 193 bytes bytes, which is going to be about there. There we go. So we can see the length in the bottom here says C1, so it matches that first byte. That is the key, the RC4 passphrase of the rest of the content to decrypt it. So what we can do is just Control and C that. We're going to stick this into CyberChef. We'll use a passphrase here, change this to hexadecimal input. I'm also going to change the input format of the bytes that we're going to feed it as hexadecimal as well. And what we can do there, get rid of all of this because that is just stuff to do with the key. Copy the rest of the data, stick this into CyberChef, and now we can see, there you go, is the decrypted content of the config itself. And the first thing in that config is the C2 that's going to receive all of the stolen data. In this case, it's server.killwhenabuse1.xyz port 1168, and you can see some other artifacts as well. So that is how you dump the config from Remcos. That is how you decode it, and no matter what the length of the key is, you'll always be able to find what the key is by using the first byte as the length of the key, taking the next lot of bytes, whatever that length may be, using that as the input to RC4 as the key, and then the rest of the code will be decrypted nice and easily for you without any hassle whatsoever. Super easy to do. Hopefully that's of use to you. Okay, thanks very much for checking out this video, YouTube. I really do appreciate your questions, your comments, your likes as well. If you do like the video, please give it the thumbs up. If you want to see more content, please subscribe. Also, you can check me out on Twitter as well, at CyberCDH. I look forward to seeing you there. Take it easy, keep well, until next time.